I'm James, first of all. I go by sort of many titles in Android. A platform engineer, custom ROM maintainer. It's more on the low level, so that'll probably give you an insight to what this talk will be about, as the title intends, which is Android open source and what we can do more with Android. So it's a good question. It's a very open topic, so we'll dive straight into it. So, why is Android open source and why is it important? There's three main keywords which come to mind when discussing this topic, which are distribute, establish, and expand. Um, Obviously, we know that Google is in possession of the Android trademark and maintains the Android source code. So any updates which come to Android come directly from Google via different branches and tags. Obviously, you may know with different Android versions. There's many changes which go behind the hood. So many people spending their time and resources to keep Android alive as a project. And obviously, as developers, AOSP, the Android open source project, known in longer terms, helps many developers like me who were enthusiastic from the beginning and never sort of had a job related to Android, get their hands dirty with Android, experiment, obviously either on the higher level or the lower level of the source code. So from the operating system upwards is all available. And yeah, there's many opportunities which come from this. Obviously, this establishes the Android ecosystem, so everything works with each other and it works efficiently so that repositories and distributions which are needed within the Android operating system to be built um, are set up properly and can be compiled, tested, and distributed as accordingly. This obviously helps expand the popularity of the operating system, not just with tinkerers and developers like us, but also with larger companies, since this is a head start to their advancement, especially in telecommunications with phones and whatnot, but also implementing their own services on top of the layers shown over here in the diagram, which explains the differences between the HALs, the Android runtime, the libraries, and the frameworks, and obviously the apps on top. But yeah, it's a very good way to integrate your apps tightly with the user experience, the GUI, and mobile devices with specifications making more sense later on. So let's say some groundwork, okay? As you can see here, there's an endless list of repositories. That's what they're called. You might be asking, what are they for? Why are there so many? And how does this actually compile Android? So the source is straight from Google, as you can see. The link is android.googlesource.com. From there, you can fetch AOSP and its components in individual repositories and synchronize them in an environment. So when building Android and taking the whole picture, it is ideal to use the repo tool to synchronize the whole code, and then you start making modifications to your operating system or packages which go on top of Android to satisfy your aim and purpose. So that's exactly what it's for. Um, so don't be frightened by how much there are. You don't need to, you don't have to use them all. You can use single ones at a time. But in the case where you're building Android for devices which need them, or you're introducing new libraries and you want to test them for your ROM or system, you can do so as accordingly. Platform repositories resemble the more specific Android repositories. So that means frameworks, which is a very big subject to talk about since there are many lower level codes and logic which go through. The packages are the apps. So you can have packages slash apps and your own app or like a wallpaper service, everything which constructs Android to be used apart from your system and settings app. So yeah, that is important. And what I like doing most as a device engineer is using the device repositories, which come in forms of device tree, kernel, and vendor blobs, which enable the Android firmware to be built specifically for the specifications and models set for that device. So yeah, that's important to keep in mind. Any changes going in those repositories allows the changes to be made on a device level modification. So if that's solving a bug, adding a new flag, and implementing new feature sets for that hardware and specifications specifically, you could do that. And that's how you compile the Android operating system. Okay, so before you get started, a bit of prerequisites you need. So obviously, it's a tight integration with all, and you need quite a good system to build an operating system on top of yours, you know? So obviously, the highlight here is using a Linux distribution, most popular being Ubuntu, with its packages being very easy to download, and the compiler is working in an efficient manner, such as clang and CMake, make, GCC, which even on a kernel level basis is quite more important that this package is used efficiently. Obviously, you need a good CPU to ensure that you can crunch that code in a timely manner and that no errors are made. So your CPU isn't doing a catch-up work with the compiling of the Android source code. And enough RAM and C cache is being used to quickly transfer files to and from your hard disk or SSD. So obviously your time can be reduced, or you don't confuse the compiler in any way that there's any hiccups. Obviously, Linux distribution needs to be based on AMD 64. x86 processors are ideal. Not sure you can compile on ARM, but there might be a future where that is useful, especially with newer computers investing in their own SoCs. Device binaries are important, so especially once you get into more lower level stuff, it's important that you have, for example, a phone source code which is up to date. Google makes it easy for people like me who own Google Pixel devices to fetch the device source code directly from their AOSP and Google source library. So yeah, make sure that's a thing. Make sure you have a base tree and a base kernel. So if you're aiming to build for a device, you can do that in a very easy and logical manner. The build toolchains are important, as mentioned before, GCC, clang. Although GCC is no longer being used mainstream for kernel compiling, since many kernels just switch to clang since it's more efficient. Build Essentials is also a very good thing to have, obviously, to make sure that your environment is set up to have commands at disposal. So in short, in your environment, the build repository will ensure that env setup, the script file, will run through all your Android environment and ensure that commands like lunch and brunch, which are basically make commands, will be initialized as accordingly. And as mentioned before, all that source code needs a way to be synchronized. So the repo tool will come handy there, as there's many manifests, which we will discuss very close to the slide, will be used to indicate the repo tool to what it needs to download and sort. So let's talk about manifests. Manifests are used all over Android. You can use them in device repositories and even in framework repositories. They can do many things. They're obviously XML files with different purposes, but from where it begins, we'll talk about it with the repo tool. So it's an index, sort of. Let's keep it simple and call it an index, where a remote, a branch, and a destination will be specified. So if I have, as mentioned before, frameworks and packages being downloaded in correlation with an Android environment, I can specify those in the XML file. If I want to add more and remove some because there's some deprecations, or maybe You don't need the device repositories from Google, which are in the default manifest, platform/manifest on the Google source code, which you may not need. You can also add your own XML file to indicate that you do not need to synchronize those repositories. So it's customizable, it's easy to use, and yeah, you should definitely take a look at it, even planning before to see what you need and how big your Android environment will come to be after it's synchronized. You can specify obviously flags to speed up and use more cores with the -j flag. Local manifest is what goes on top of the default manifest. So as mentioned before, with those modifications, you can sort of call those a local manifest yourself, and they can help us in many ways, especially if you're constrained with internet connection and you don't want to wait any longer to download unwanted material. So simple as 3 commands, even 2 commands, if you don't consider the making of the directory. So as you can see here, I have a small sort of GIF to indicate how simple it is to get started. So make the directory, initialize the repository, specifying a branch, which is in this case 12.1 R7, which is a tag and a branch of 12L, which came out back in July when the stock was initially prepared. And following that, as mentioned before, repo sync. So this is your initial thing. It's a bit of a waiting game, but I assure you that the results of this will be worth it in the future. So yeah, that's how you get started. As you can see there, I'll just sync it and it goes away. So make a cup of tea, come back when it's time to build. So after the wait does indeed come the work. So I mentioned before how the Android environment is set up, and now we'll be interacting with the Android environment in itself. So it's done by 3 easy steps before modifying your source code. So if you want to make any changes, device-wise, framework-wise, apps, do that before this step, where you have to set up the environment with .build/env setup.sh, a small script which will get you started with plenty full of commands, which will come in handy as shown with launch. So if I have a target, let's say I have a device, it has a code name Sargo, so that's Pixel 3a, for example. I launch AOSP Sargo user debug. User debug is the build variant, so according to your use case, user debug, engineering build, that will help you set flags and give extra features or utilities which may come in handy, especially as a developer where you're not sure your device will work with Android out of the box completely. So ENG will help specify the device's flags to have ADB running on boot, for example. So if you're boot looping and you don't know what's going on, the engineering builds will definitely come in handy there. But if it's a release build and you don't need these user debugs, or you don't want the user to interact with the lower level of Android, and there's no worries and you just want to release it, that's exactly what you want to do. You want to use user. And finally, you make the code. So it could be used as make, m by default. OTA package will just specify the out directory. So in this case, the OTA package will be a flashable zip file, which you could sideload to your device and see if your end product is what you want. So begs the question, why do we do all this? Why should we develop with AOSP? So as developers, this is really handy since it's free of charge. Obviously, I don't need to pay anything to download and modify the Android source code for myself. And obviously, Android is a big platform. So given all the background that Google has with Android, and Android by itself before being bought out by Google, helps you benefit from all the feature sets and the stability that we have today, especially with Android 13. There are obviously updates coming out on day 1. So if you have a new branch or version set of Android, which came out, say, last August, like Android 13, and previously with Android 12 and 11, you could make use of the source code as a developer on day one. So that's something very important for me as a developer. If I want to bring up older devices to a newer Android version as soon as it comes out, I can get started on day one, sleepless nights, and that's how it goes. So um, it, that's a very good benefit, and especially on a bigger company level, speak about OEMs and having their own device platforms where they have their own apps to deal with even later on. This will be a very good head start um, for that, especially even with security patches coming out on a monthly basis. So if that's the October security patch that came out this month, or the November security patch is coming out next month, you can get those changes as soon as they're out and make those modifications to your own existing environment. So that's a very good benefit. And from these benefits come a lot of development. So um, since AOSP is open to everyone, as mentioned before, bigger companies can make use of Android by including their own services and their own GUI, skin, you name it, it's all there. They can make use of it on top of base Android with those layers, which I showed in the first slide, being consistent. So if there's a change happening on one version, it can be transitioned to the other one, knowing that AOSP is intact the same way on the different version. Obviously, that helps expand the platform at no extra cost. And at the end of the day, that is what I did, and that's what got me into AOSP and Android development. So let's speak about custom ROMs. Obviously, this is a benefit which comes from AOSP. So if you don't know about custom ROMs, heard of them maybe, or you weren't adventurous enough, or your device wasn't compatible with any famous known custom ROM, I'll give you a brief overview of what they are. They are basically, in short, custom distributions of the Android operating system. So we're using AOSP with their free-to-use repositories. Custom ROMs have an aim and purpose. If they want to expand to many devices which are become unofficially supported after their lifespan has ended on their stock experience from the OEM, custom ROMs are a very good alternative given enough resources and enough development to provide a stable experience for the user. And yeah, they're very versatile. You can see different changes coming from one custom ROM to another, each of which having their own benefit. If that's focusing on a minimalistic approach and user interface, or just like removing bloatware, they can be used for many reasons, and they are specifically built by maintainers who build this different version of Android for that particular device in mind. So if it has a feature set, specifications, if it has this type of hardware, it will be considered the full resolution for a screen, for example, or like a sensor, which is used only on a device. It will be in mind when developing custom ROMs for the device. It comes with a lot of work, though. Obviously, it takes a team to do most things, which are a big project. Custom ROMs are not different. They require the people who maintain the source code, as mentioned, with security patches and updates, versions, feature sets. Those need to keep up to date, and they need to stay in mind when developing custom ROMs. For the safety of the user, it is worth knowing that custom ROMs require the unlocking of the bootloader. So when installing these custom ROMs, you are unlocking your device's bootloader and leaving out exploits or whatever in concern in that department. But there is ongoing development to lock bootloaders to work with custom ROMs by signing them. But that's something obviously you need to consider, and you need to prioritize when it comes to custom ROMs or staying to stock ROM as wanted by the OEM. Obviously, to install these, you need a custom recovery, which is flashed on top or like booted on top. And from there, you can wipe your device, remove the old software, and flash the new one on it. If that's Android 13, from an older version of Android you might have come from with a different skin, you can change it up a bit and daily drive that or keep it as a secondary device, which is also a very good benefit. You can make these, obviously, as told before, it's no different. It's basically AOSP. So Any changes made will convert to here. The commands, the build env setup remains constant within. Maybe the commands will change a bit, but on the whole, the principle remains the same. These are some examples, obviously. NinjaOS being the most known within enthusiasts and maybe people who are still wanting to get into custom ROMs distribution and even learn more about them. Lineage provides less bloatware. It's very basic to source AOSP, but in a way that you can develop your own apps on top of them, so you can get a different feel. Overall, very stable, even on official branches. So there's a whole team dedicated to it. There's a whole server going on a nightly basis, even as well, to ensure that updates come out on a daily basis. So NinjaOS is a very good starter custom ROM, in my opinion, especially when you're looking for something new on a less known device as well. Paranoid Android has a different feel. It has a different UX experience. They focus on also on CAF, which is Code Aurora source. So if your device actually supports that, you can take advantage of code coming directly from Qualcomm, which is more optimized. And overall, a very good option. So if your device supports Paranoid Android, even if it doesn't, consider taking a look at it. So even in the future, you could develop for that custom ROM. Personally, from experience, I have a very close contact with Pixel Experience, which is built over AOSP, ensures that the user can get the latest Google Pixel features, even on a non-Google Pixel device. So that's implementing gaps, so Google apps, on top of the stock ROM. So you have all those Google services and goodies, like the feature drops, security patches, and whatnot on day one. So that's a very good benefit to Pixel Experience, and definitely why it's a good choice for me and many other developers. So obviously custom ROMs, I mentioned, need a lot of work. So in short, I'll divide them in two: AOSP engineers and device engineers, which work together. So AOSP engineers have a bigger task looking over viewing many devices which use the same source code. So that's a framework base, packages, and you know it, vendors. They make sure that these remain stable and up to date, including new features for your updates and your releases. Many platforms like Gerrit allow teams to propose new commits in a way that you can collaborate and comment before approving and merging it, so no mistakes are made in the later stage. Device engineers, in the meantime, have to maintain the device, the kernel, and the vendor source code for the respective devices to ensure that they're still working with the newer versions, and there's less bugs, obviously, with time. So all of this results in a very healthy product for custom ROMs. So let's imagine a future with custom ROMs. Obviously, you heard the benefits of them, but what more could we bring out from this? So I'd like to imagine a future where post support of your device, you can easily rely on a custom ROM so that you can make further use of maybe 3 years of software update while ensuring what you get is what you want. So if there's a feature set you want, it's there, you know. This custom ROM can promise it and it can guarantee it on a very good level with proper stability and a working team behind it, which allows for many possibilities. This helps, obviously, the environment. When disposing of a phone, you have a second chance to think about it and see what the community can develop for you or what you can invest your time with to develop with and learn something new. So instead of piling up all your phones into a recycling bin or whatever, this is a good alternative. But you might be asking, what if my device at a hardware and even like a product stage does not support it? You can always improvise. Obviously, throughout my developing experience with Android and using it, different devices, different ecosystems, different systems, I've seen many different situations where I lost a bit of courage, but you can always improvise as a community backing you. So seek help for any issues, errors, or like faults you may have, and improvise. So you're not alone in this. There's many people who own the same device as you, and many enthusiasts who care also heavily about this. So that's all I have to say. Thank you for hearing my talk out over here. If you have any questions, please use the Q&A section. I'll be happy to read them out. There's already two, which is good. I'll get to them as soon as I can. There's also my links over here. So if you need any contact with me or my source code, make sure to visit my GitHub. And yeah, you can have my latest updates on my website and on my Twitter. Okay, so I have a question from Sasba. What could be done on AOSP would have a most recent Linux kernel? So Linux kernels are obviously important. Devices need a kernel, which is the brain of most of what happens on a lower level for devices. Obviously, kernels can be backported. So if you have an older version of a kernel using an older Linux version, newer feature sets could be backported to those. But at the same time, upgrading to a new Linux version is very good for your device and a good principle if it can happen, since many security changes and patches can be implemented in an easy manner and a consistent manner with, for example, Linux version 5. So I hope that responded to your question, but yes, Linux versions are quite important. Following that, speaking about OTAs, very good implementation. Also very practical within custom ROMs nowadays, so that updates come directly to the user, even with A and B partitions, so that seamless updates could be carried out. Using OTA allows for patches to be merged and built, like firmware can be built and distributed in an easy manner where a PC can't be used, for example. Obviously, you're mentioning that they could lag behind where they wouldn't lag behind. It's a good principle for a custom ROM, for example, to have a unified system on where there's firmware and builds can be uploaded. I see that as a good principle to have, so you won't lag behind. So, for example, Pixel Experience has a common server and a common release mirror. So for OTAs, it's quite easy. You deploy a build given lack of queue or whatever for building times. It gives an efficient approach and very quick updates. So I see that as a very good response to that issue. So next we have you tried to modify interactions with the hull layer, or what challenges have you heard from those who have? So obviously hulls do change with Android versions, and that's principally most where you encounter changes, especially with an older device. Say I have an old device which doesn't support the newer power hull. That's a challenge, for example. Sometimes you need to bring up your own hull in a device repository, which is a bit makeshifted or hacky. So that's a challenge which I encountered. Obviously, this could cause big issues like boot loops initially, where you take logs and then you notice that there is an issue with the hull layer. So yeah, a very good question and a very open answer. So hulls need to be considered even according to your SoC. So Qualcomm also supports their own hulls for data services and sorts. So yeah, for older devices, this might be an issue, and that's, for me, the most challenging approach as a device engineer. Finally, we have what is a good starter project? I can tell you from personal experience that anything is a good starter project. If you're starting with a custom ROM, you're starting with AOSP directly, it's always good to tinker with an AOSP distribution. Um, as you learn a lot, you understand exactly how things are flowing in the Android system and Android environment. So take a peek at AOSP, check your devices if you have any secondary or tertiary devices. See if there's any support for those so you can make use of open source trees and commits which have been made over the years. So that, yeah, you could have a head start and an easy transition to learning AOSP. So I hope that covered any questions. If anybody has any more, feel free to pop in as soon as you can. But even if you have any questions afterwards, you can contact me as shown in the last slide. My contacts are there. And if I'm around, feel free to say hi or ask your question there. Thank you.
Nice. That was a wonderful talk. Very like refreshing angle, I think, for our community on the, in the Android sphere. So thank you, James, so much.